Imagine something so massive that it outweighs every single star in the Milky Way galaxy combined. Not a few stars, not 1,000 stars, all 200 to 400 billion of them. Every sun you have ever seen in the night sky. Every star and every image the Hubble telescope has ever captured of our galaxy. All of it. Its name is Ton 618. It is a black hole. And it is, by every measure we have, the largest single object in the observable universe. Its event horizon, the boundary beyond which nothing can return, is so wide that it would take light itself over a week to cross from one side to the other. We are going to put that into perspective today. And when we are done, you will understand why the universe should not be able to make something like this at all. Black holes come in several sizes. The smallest are stellar black holes, formed when massive stars collapse at the end of their lives. They typically weigh between 5 and 20 times the mass of our Sun. Compact, dense, and common throughout the galaxy. Then there are supermassive black holes, the giants that sit at the centers of galaxies. Our own Milky Way has one, Sagittarius A, with a mass of approximately 4 million suns. The famous black hole at the center of galaxy M87, the first ever directly photographed, weighs in at 6.5 billion solar masses. Those numbers sound enormous, but in the world of Ton 618, they are almost trivial. Ton 618 belongs to an entirely different category, a category so extreme that astronomers have proposed creating a new classification just for it, the ultramassive black hole. Its mass is estimated at 66 billion times the mass of our Sun. That is not a typo. 66 billion. And the universe made it less than 3.5 billion years after the Big Bang. How something this big exists, and how the cosmos built it so fast, is one of the deepest unsolved mysteries in astrophysics. Today, we are going to find out everything we know. In 1957, two Mexican astronomers, Braulio Iriar and Enrique Chavira, were conducting a survey of faint blue stars from the Tonantzintla Observatory in the mountains of Puebla, Mexico, using a small 7-meter Schmidt telescope. They photographed a region of sky near the border of two constellations, Canes Venatici, the hunting dogs, and Coma Berenices. Among the images was an object that appeared in their notes, decidedly violet. They catalogued it as number 618. They had no idea what it was because in 1957, nobody did. The concept of a quasar would not be established for another 6 years. In 1970, a radio survey conducted in Bologna, Italy, detected radio emissions coming from Ton 618. That changed everything. Radio emissions of that kind are the fingerprint of a quasar, an active galactic nucleus powered by a supermassive black hole consuming material at enormous rates. Further optical observations confirmed it. What had appeared to be a faint star in a survey photograph was, in reality, a cosmic engine burning 8 billion light-years away. Those photons that hit Iriar's photographic plates in 1957 had been traveling through space since before our solar system existed. Ton 618 is not simply a black hole. It is a quasar, one of the most powerful classes of object in the universe. A quasar forms when a supermassive black hole at the center of a galaxy is actively feeding. As enormous quantities of gas and dust fall toward the black hole, they form a rotating structure called an accretion disk. The material in this disk is compressed and heated to temperatures of millions of degrees by friction and gravitational forces. It glows brilliantly across every wavelength of light, from radio waves to X-rays. Ton 618 is not just any quasar. It is hyperluminous, meaning it ranks among the brightest objects ever detected in the observable universe. Its luminosity is approximately 140 trillion times that of our Sun. Let that number sit for a moment. 140 trillion suns worth of light pouring out from a single region of space smaller than our solar system. It shines so brightly that it completely overwhelms the galaxy surrounding it. That galaxy is almost certainly there. Ton 618 must be sitting at the center of something, but it cannot be detected from Earth because the quasar drowns it out entirely. Let us now confront the size of Ton 618 directly. And to do that, we need some reference points. Our Sun is about 4 million kilometers in diameter. The orbit of Neptune, the outermost planet in our solar system, sits about 4-5 billion kilometers from the Sun, meaning our entire solar system spans roughly 9 billion kilometers across. The event horizon of Ton 618, the point of no return, the boundary of the black hole itself, has a radius of 1,300 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. So the event horizon of Ton 618 extends 1,300 times the Earth-Sun distance in every direction from its center. In practical terms, the event horizon of Ton 618 is more than 40 times wider than the entire orbit of Neptune. You could fit our entire solar system inside this black hole's event horizon more than 40 times over. And if you were somehow standing at the edge of that event horizon, you would need to travel at the speed of light for roughly 10 days to cross from one side to the other. The mass driving all of this, 66 billion solar masses, is heavier than every star in the Milky Way combined. The light we see from Ton 618 is not old news in any comfortable sense. The photons reaching our telescopes today left Ton 618 approximately 8 billion years ago, when the universe was only a fraction of its current age. We are seeing this object as it was in its violent, furious youth. And in that youth, it was feeding at a rate that staggers imagination. Gas falling into the accretion disk of Ton 618 has been measured traveling at up to 10,500 kilometers per second. That is over 3% of the speed of light. This is not slow, gradual accumulation. This is violent, turbulent, relativistic consumption. The friction and radiation pressure generated by this infalling material creates the quasar's extraordinary luminosity. But it also means the black hole is growing. Every second, new material crosses the event horizon and is added to the black hole's mass, permanently and irreversibly. Astronomers have also confirmed that Ton 618 is surrounded by an enormous cloud of hydrogen gas called a Lyman-alpha blob. Observations with the ALMA telescope in Chile confirmed in 2021 that this structure spans over 330,000 light years, more than 3 times the diameter of the entire Milky Way. This vast nebula is thought to be ionized and energized by the quasar's radiation, glowing with light that we can only detect in the ultraviolet. Here is where ton 618 becomes deeply uncomfortable for physicists. The universe was born approximately 8 billion years ago. Ton 618's light has been traveling for 8 billion years. That means we are seeing it as it existed just 3 billion years after the Big Bang. In those first 3 billion years, the universe had to create the first stars, let those stars live and die to produce the first black holes, and then somehow grow one of those black holes from a few tens of solar masses all the way to 66 billion solar masses. Under normal accretion physics, governed by what is called the Eddington limit, the theoretical maximum rate at which a black hole can consume material before its own radiation pushes the infalling gas away. Growing a black hole to 66 billion solar masses in 3 billion years is essentially impossible. Theorists have proposed 3 possible explanations. The first is super-Eddington accretion, that in the dense, gas-rich environment of the early universe, black holes were able to consume material 10 to 100 times faster than the Eddington limit allows, possibly enabled by specific geometric conditions that let gas fall in from certain directions, even as radiation pressure pushes it away in others. The second is direct collapse. Instead of forming from a stellar remnant and growing slowly, these seed black holes may have formed directly from the collapse of enormous gas clouds in the early universe, already massive from the start, skipping the small phase entirely. The third possibility is a series of rapid mergers, black holes colliding and merging repeatedly in the crowded conditions of the early universe, doubling in mass with each collision. The honest answer is that we do not yet know which, if any, of these mechanisms is correct. Ton 618 sits at the boundary of what our models can explain. Here is something strange to hold in your mind. The light from ton 618 shows us a quasar in full violent activity, blazing, consuming, growing. But that light left 8 billion years ago. The actual ton 618 in the present moment, wherever and whatever it is now, has aged by nearly 11 billion years since those photons set off toward us. Quasars are not permanent. They are a phase. When the gas surrounding a black hole is eventually depleted, the feeding slows. The accretion disk fades. The blazing luminosity dims. The quasar dies, and what is left is simply a quiet, dark, colossal black hole sitting at the center of a galaxy that nobody can see anymore. Ton 618, right now, in the actual present, accounting for the time it would take light to arrive, has almost certainly quieted. It is likely no longer a quasar. The 66 billion solar mass black hole that powered one of the most luminous objects in the early universe is now, in all probability, sitting dark and silent at the heart of a massive galaxy, surrounded by stars that orbit it in peaceful, oblivious arcs. We will never be able to confirm this in any human timescale. We will always see ton 618 as it was, never as it is. We said at the beginning that ton 618 outweighs every star in the Milky Way combined. Let us close the loop on that. because the full implication deserves your complete attention. The Milky Way contains somewhere between 200 and 400 billion stars. Our Sun alone is 333,000 times the mass of the Earth. Multiply that by 400 billion. That is the mass of every star in our galaxy. Ton 618 is heavier. But here is the part that should genuinely silence you. Astronomers believe the Milky Way itself, our galaxy, our home, once had a quasar phase. Billions of years ago, Sagittarius A was almost certainly feeding and blazing just as Ton 618 once did. The Milky Way was once something like Ton 618. It quieted, it calmed, the gas was used up. And billions of years later, life appeared on a small rocky planet orbiting an ordinary star, 26,000 light-years from a black hole that was once one of the most violent objects in the universe. We are here because a quasar grew quiet. Ton 618, 66 billion solar masses, an event horizon wider than 40 solar systems, a luminosity of 140 trillion suns, and a formation story that still has no complete answer, sitting 8 billion light-years away, showing us a universe that was far more violent, far more extreme, and far more creative than anything we thought possible. It is the largest thing we have ever found, and whatever it is doing right now, we may never know. If this video left you staring at the ceiling, subscribe to Universa Stuff for a new journey into the cosmos every week. Next time, we go even deeper, exploring the black hole that should not exist, found by the James Webb Space Telescope just 570 million years after the Big Bang. It makes even Ton 618 look like it had all the time in the world.